Alright, let's solve the 2D Leetcode question, and sorry for being late. I was trying to understand the problem by myself, and it is too much mathematics information. So we're given a 2D integer array of points where the points of index is represent the x and y coordinate in the Cartesian plane. So the what in the Cartesian plane is just the x, y coordinate on the plane. And the horizontal trapezoid mean this is like something like Golf's quadrilateral with at least one pair of horizontal side. So if we want to find the horizontal trapezoid, that means at least one line in here must be parallel with the x-axis, which is in here. So two lines are parallel if only have the same slope. So if they have the same slope, they can two lines can parallel to the x-axis. So we have to return the unique horizontal trapezoids that can be found by choosing the four distant points from the points. So we have to choose a point within the given points, since the answer may be very large. So we have to return it by the 10 power 9 like 7 modulo. So yeah, let's go through the asymmetry one by one. Since this is a little bit difficult to explain, luckily I have well prepared the coordinate for Earths. Yep, that's my ugly coordinates, and let's get along with that. And now we're trying to explain as much as I can to tackle that. I'm also pretty sure I won't be able to tackle the answer on the spot if I got this question during the interviews. Yep, so let's go for the example 1. We are given like the point system in here, which are like 1, 0, 2, 0, and 3, 0, and 2, 2, and 3, 2. So if we analyze this problem, we have like 3 y in the same coordinates and then 2 y in the same coordinates. So by dropping the points in here, so we have like 1, 0, 1 is x, 0 is y, so it's in here, one block, 2, 0, which is here, 3, 0, which is here, and then 2, 2, which is here, and 3, 2, which is here. So if I have to draw the ugly possibility, that is the given points. So what we need to do is we have to search the horizontal trapezoid. So how can we find the horizontal trapezoid? At least we have one x-axis that must be parallel with our existing points in here, which represent the something like this one, which is parallel with the x-axis. So according to this example, right, by using the different parallel point, so technically this is just a pure rectangle in here, and then that is parallel to the x-axis. That is the one trapezoid. But we may have a question: why don't we choose things like this? That it can be the trapezoid. Yeah, that is also possible, but we need to have a unique, and then that should be based on their requirement. We should be choosing the distant point from the points. So we cannot choose the same points again. The same, that is also the one of the horizontal trapezoid. That is also the one of the trapezoid. What? How can I tackle that problem is I will count how many points of lines are parallel to the y axis. So that will make us a better understanding of what we want to find on the spot. So let's try to tackle with the code along the way, and I will try to explain. So yep, let's try to calculate the frequency of how many y point we see, and by keeping it like dictionary, what I'm going to do is let's call like point and points, and then let's call y, which is a point of 1. Since 0 is a x, 1 is a y, so I'm going to update the frequency of dictionary y will be the plus equal to 1. Just incrementing the y every time we see it, but we need to consider for the default situation, which is 0 in here. And next is let's create the variable called mob. Just want to save the performance instead of like multiplying addition of the 10 power 9 plus 7. Let's create like this: 1 2 3 and this is 7. So that is a mod given by here for the modulo. And then we will need the one variable called answer. So that is to calculate how many horizontal trapezoid that we can find along the way. Let's try to go to it. Let's see let's call it a count, since we are calculating the points in here. Okay, let's count in frequency, return answer. Okay, just for sake of the better understanding, I will try to print the frequency in here. So if we see in here, we're gonna see like 0 with the 3, 2 with the 2, 0 with the 3, 2 with the 2. In here, 0 2 1 2, 0 2 1 2. That is what I'm doing in here. Since we have got the point for the y, what I'm going to do in here is I'm gonna count to check like if the count is greater than or equal to 2. If the reason why I have to check like it's greater than or equal to 2, if there's no minimum 2 points of y, that's technically mean like there's no y points in here, mean that we are fluctuate and stuck in this portion only. Let's say like we have 2 y point in here. Look, this is 1 y, this is 1 y, and this is 1 y. This is also y, because we have like 5 y's that can be found. But what we actually count is we have a count of 3 in here, 2 in here. So in that case, what I could do is let's calculate the weights. So if the count minus 1, the reason why I'm choosing the count minus 1, we have to choose different distinct numbers in here instead of like choosing the same number. That's why I'm deducting the 1, and then I'm gonna multiplying with the same count. So which will give us the how many points we can find from the given number of weights, and I need to divide it by 2. The reason why I need to divide it by 2 is okay, let's consider like this is a point A. Okay, how to write it? Point A. Alright, I just write it. We have like 5 points, right? A, B, C, and D, and E. So, okay, that's a very terrible naming. Let's call it A, B, C, and D, and next will be the E, since we only have 5 points. So this is A. Let's delete the ugly A. This is A we got. We have a B, we have a C, we have a D, and we have an E. Since these points are linking to each other like links, I only need the half of the points. The reason why I only need the half point is since A is related to B, B is also linked with the A. So by taking all the 5 points, that will create as a more difficulty to calculate in the near future. So what I'm doing is that divide all the counts by 2, and then at that time I can calculate the answer already. The answer is what I was thinking is multiplying the answer with the whales, and then we need to keep track of the one previous variable, and like how many previous horizontal trapezoid we have found in above, and then I'm gonna multiply with the previous approach, and then we can mod with that in here. If yes, we just update the previous with the weights. Yeah, that is what I was researching for the whole day, and that is the only best optimal answer I could find. And then if I have to mention the time complexity and split complexity, that would be the O of wait, what did I do wrong in here? If count, oh wait, I need to get the values only. Yeah, so that is the optimal I could find today. And then both space and time complexity will be the O of n for each. Yep, that solved the problem, and very sorry for the terrible explanation. I also trying to get it understand, but I have no idea what is the better visualization to explain all these code. Yep, we're trying the best in the next time, and then see you in the next video. Bye.